Hello YouTube, welcome to another Project Euler tutorial. This is problem 5, smallest multiple. 2520 is the smallest number that can be divided by each of the numbers 1 through 10 without any remainder. What's the smallest positive number that is evenly divisible by all of the numbers from 1 to 20? Okay, starting off, you may be thinking, how can I possibly check all of these numbers efficiently? I actually had that problem to start with. The first time I did this, my implementation took around 10 seconds to complete, which I have further improved upon. If you take this number 20, it's the biggest number you will ever need to check, so why not make that your step? Whenever you're increasing the numbers, increase it by 20 every time. Also, since 2 evenly goes into 20 and 1 evenly divides into every number, you can easily start with 3 to 19. And hopefully that will improve your improve your time. So let's get started. Final int start div, which stands for divisor, that will start at 3, and the step will equal 20. So all we need to do now is loop through until we find our answer. So for int I equals step, because we're starting at 20, and we want it to go on forever, so no condition, I plus equals step. So it's going to increase by 20 each time. Boolean all values. This is going to tell our condition if all of the numbers from 1 to 20 are divisible into I. This is going to be the only way it will be able to check. So now we're going to go from 3 to 19 and determine if each one can go into I. So for k, k is less than step, k plus plus. So if I modulus k does not equal 0, then all values will equal false. Reason we're testing why it's not is because as soon as we encounter a number that's not in I, it will break out of this loop and save us a lot of time with our implementation. So that's actually all we need to do right there. So down here we want to say if all values is true, so if 1 through 20 can go into I every time, then we want to system.out.printf percent comma d is the smallest multiple. This will be our answer. And right here we'll go I. And then we will break this afterwards to end our loop. And the answer is indeed 232,792,560. So right here we started at 3 because it will be faster in our implementation, and we increase by 20 each time since it's our largest number. All values is our flag, or a sentinel, I guess, to determine when to end this loop. This will test each number 1 through 20 to see if it goes into I evenly. And that's our entire program. Thank you for watching.